So the next aspect on acid-base concept is what we call, where's my black marker, is what we call Ostward dilution law. If you look at the Ostward dilution law, this law is the one that helps us to understand the behavior of weak acid, behavior of what? Of weak acid and a what? And a weak base in what? In solution. So the what? The Ostward dilute what? Dilution law. The purpose of this law or the aim of this law is what? Is the one that is explained the behavior of weak acid, weak electrolytes, and a weak electrolyte or weak acid and what? And a weak base in the what? In solution for us. So the law that is explaining the behavior of what? Of weak electrolyte or weak acid or weak base for us in solution is what? Ostward dilution, what? Dilution law. And this Ostward dilution law, it can also help us to what? To prepare a buffer what? Buffer solution. Buffer what? Solution. It's also the one that they describe the buffer solution for us. It's also the one that is what? Explain the behavior of weak electrolyte for us in what? In solution. And this it can also use to what? To determine the degree of dissociation constant of a solution. So what is Ostward dilution law? This states that this states that degree of dissociation of weak electrolyte or weak what? Electrolytes increase as the concentration of the solution decrease. Yes, the says that degree of solution of weak electrolytes, yes, increase as concentration of the solution, the what? Decrease. Mathematically, the Oxford dilutions, or it will be expressed degree of derivation square root of what? The derivation constant multiplied by what? V. This is the formula for what? Degree of what? Of the so what? Dissociation. Where what? Where alpha is what? Degree of dissociation. And look at what? Ka is what? Dissociation constant, and V is volume in DMQ. So this is what? Formula for what? For degree of dissociation by Ostward dilution what? Rules. And don't forget, I said this Ostward dilution rule has three functions. The first one is what? Is the one that is help us to what? To understand the behavior of what? Of electrolytes. Weak electrolytes in solution. Is weak acid and what? And weak base. It's also the one that is what? Help us to what? To derive or to understand the bubble what? Solution. And we can also use what? This Ostward dilution law to what? To determine dissociation what? Constant. So the Ostward what? Dilution law under it has three application. So from this law now, we can prove this formula. This K is what? Dissociation constant. V is volume, degree of dissociation. We can prove it. Let's go. Now, if we have a reaction of A acid dissolved in aqueous solution, it will give us what? I need space. I need space. Let me say, a reaction of HA dissolved in aqueous water to give us what? H plus A, H what? Plus A minus. This is also in what? In aqueous. In aqueous. In what? Aqueous. So let us say what? The mole initial and then we also have mole at equal what? Mole initial and mole at what? Equilibrium. So the number of mole of HA here as initial, the number of mole of HA as initial is what? Is 1. So if the same with initial, that is the reaction is never commenced, never starts. So when reaction is never starts, what do we have in the product? You must have 0. 0. That is what? We never start the what? The reaction. But the initial mole for this HA is what? Is 1. But when the reaction never what? Commence, the product side we have 0, 0. Abi now? But when this what? We have 1 here again, Abi, and the reaction now what? Commence at equilibrium, and this one now produce 1 alpha here. So you observe that what? This alpha that is formed here at the product came from what? From 1. Assume I'm having 1 mole of a salt in my hand now. So when I'm started what? Eating it, I consume 0.4 mole of what? Of salt. What will left with me is what? 1 mole minus 0.4, Abi? So assume this is the mole I have in my hand, this is what I consume. So what left in my hand now, it will be what? Alpha, 1 minus what? Minus alpha. So this one you have what? At the equilibrium. And hope you could still remember under mole concept, there is a formula called what? The mole equal to the what? CV. The mole is what? The concentration multiplied by what? By volume. From this expression, what do we have? We can have what? C should be what? N over what? Over V. But yeah, let us find the concentration for this HA, HA and A minus. Can I say what? Concentration for what? Let me shift a little bit. Concentration at equal what? At equilibrium. No. Let me say we have concentration. Let's find it at equilibrium. Conc will be what? Is the number of mole over what? Volume. So what is the number of mole here? The number of our mole here is what? This one will be what? 1 minus degree of dissociation over what? Over V. So what is my volume, my mole here? Is this one is 1 over 1 minus alpha. Here we have the alpha, then divided by volume, give me what? Conc. Abi? So once I can achieve this now, from the chemical equilibrium, you know, we used to write what? Equilibrium what? Constant. What is equilibrium constant for this reaction? Abi? The equilibrium constant for this reaction, Ka, equals to the what? The concentration of what? Product hydrogen plus to the concentration of what? A minus everything over what? The conc of what? H what? HA here. Abi now? I apply equilibrium constant in the chemical equilibrium to what? To write out the what? The equilibrium constant for this reaction, which is this, and then the Ka equals to the what? The conc of hydrogen ion, conc of hydrogen negative, H negative, conc of A. Good. And don't forget that what? Our this conc of A here is empty with what? With this. Conc of H is empty with this. Conc of A here is empty with this. Conc of HA is empty with what? This. Then let us what? Substitute for each there. We will now have what? Concentration. Sorry. Conc of A is equal to what? What do we have there? Is alpha dot alpha. This H here is alpha. This A here is alpha. Everything over what? HA. What is HA? Sorry, mistake. Uh-huh. Mistake. What is conc? Concentration of A equals to the what? This A is what? Alpha over V. Yes, alpha over what? V. Yes. Then this one is also what? Alpha over what? Over V. Everything over what? What do we have? We have alpha minus this over what? Over V. This A, conc of A. I use this one to replace it. I use this one to replace this one here. Then this A, I use this one to what? To replace it. How we get this? The next aspect now, as we do now, let us expand this by solving it further. Ka will give us what? Alpha square, V square, everything over what? 1 minus alpha over what? Over V. And this expression, we can also write it in this form. Ka should be equal to the what? Alpha square, V square. This will go up. V over what? 1 minus what? Alpha. This cancel 1 V here. You will now have what? The dissociation constant. Go to what? Alpha square over what? V into bracket 1 minus what? Alpha. Dissociation what? Constant. Since Ka is very small, So this Ka is very small. Therefore, this alpha is less than what? 1. Is far less than what? 1. This when this alpha is far less than 1, therefore 1 minus alpha is approximately equal to what? 1. When it's approximately equal to 1, but we now have what? Dissociation constant, what degree of constant over what? V. V times 1 will give us what? V. Volume. So what we do next now? You now have what? Degree of dissociation is equal to the what? Dissociation constant times volume. Find the square root. It will be equal to the what? Square root of what? KAV. So this is what? Ostward dilution theorem. This is the proven. So let us solve 2 or more questions on how to use what? This formula. Now let's solve this question. The first thing is what? What? Solution. This marker is not good anymore. Solution. We are given that what? 0.25 mole per dm cube solution of ethanoic acid is found to be ionized by 1.3%. Calculate the volume of acid equilibrium constant. That is, we are asked to find the what? K what? Ka here. So what is the acid given? Ethanoic acid. So this ethanoic acid is to represent our what? Our HA here. You will follow this same format here to solve this question. Well, what is here? We use HA. We are given ethanoic acid, which is what? C H3 COOH. That's what we are given. And it's found to be ionized 1.3. So when this ethanoic acid is what? Is ionized, it will give us what? CH3 of COO minus plus H plus. Abi? This CH3 COH is what? HA here. This H plus is this one here. This CH3 minus is what? It represents what? This minus what? Yeah. Good. So what can we do now? We will follow the same method at this point. But yeah, what is the initial mole given? The initial mole given from the question is what? Is 0.25. This marker is not okay too. 0. What? Is 0.25 mole per dm cube. That is what? Initial mole what? Given here. Or is the initial concentration given. So initial mole given here is this. But at initial, when reaction is never commenced, we have 0, 0. But when it's been what? Ionized, they said how many percent ionized? 1.3. So the 1.3 that is ionized is the what? 1.3% over what? 100 multiplied by what? This is 0.5 for that one. For this one too, let me check this thing. Yeah, 1.3 that is ionized is what? 1.3 that is ionized divided by 100. This percent is 100 multiplied by what? the 0.25. The same thing for this one too. 1.3 over what? This multiplied by what? 0. What? 2 what? 25. So if you press calculator here, the final answer you get here is what? 3.25 times 10 raised to power minus 3. So this same thing here too. 3.25 times 10 raised to power minus what? 3. That is what? 3.25 times 10 to the power minus 3 mole per dm cube is the concentration of what? Of CH3, CO, and hydrogen ion that is what? That is ionized. But what will be the what? The amount of concentration that is left here. So we need to subtract this from what? From here. Now let us subtract. What are you going to have? The value you get here, it will give you what? 0.25 minus 3.25 times 10 raised to the power minus what? This. So the final answer you now get here, it will be our what? The concentration what? Left. So if you now press what? Calculator, it will give us 0.247. Yes. 0.247. And at this side, we have what? 3.25 times 10 raised to the power minus this. Mole per dm cube. 3.25 times 10 to the power minus 3. Everything is mole per dm cube. We are now asked to calculate the value of equilibrium what? Constant. So to know the equilibrium constant, what will we do now? Yeah, get back to this side. Write out the equilibrium constant. Ka for this reaction, it will be concentration of what? CH3, COO minus, then conc of what? H what? Plus, over conc of everything you have there, CH what? 3, COO what? H. So the value for this, you put it here. Value for this one, you put it here. Value for this one, you put it here. Value for this one, you put it here. You get your what? Equilibrium what? Constant. Let us continue. Ka will be what? What is the value for this? We have 3.25 times 10 raised to the power minus 3. Are we? Then multiply by what? 3.25 times 10 raised to the power minus 3. Everything over what? The 0.247. So by pressing the calculator, the final answer is supposed to be 4.28 times 10 raised to the power minus 5 times 10 raised to the power minus 5 mole per dm cube. That is what? Equilibrium what? Constant for the acid. I will solve one more question on this before we move to the next aspect. Example what? Example 2. Solution. If you look at these questions, it's almost the same with this. For this one, they gave us what? Weak acid. Here, they gave us ammonia solution, which is a weak base. The percentage of ionization of ethanoic acid here is 1.3. Of ammonium chloride or ammonium solution is 0.58. Calculate the equilibrium constant for base, the same. So let's follow the same format there. What is acid given? Ammonium what? Solution. Simply means what? NH3 is ammonia. Solution dissolved in water. That is the meaning. It will ionize to give us what? Where? NH4 plus OH minus. So if that be the case, what will be the initial concentration given. The initial is what? Is 0.55. But before ionization is 0. So when it is ionized, when it is what? Ionized, we have what? The percentage here is 0.58 divided by what? Let me sheet it here. 0.58 divided by 100 multiplied by the mole given here, which is 0.055. The same thing for this one. Let me shift this thing, please. For this one too, we have what? 0.58 over 1 and 0.55. So by pressing your calculator, the final answer that we get here, if you press the calculator very well, it will give us what? 3.19. We have 3.19 times 10 raised to the power minus 3. Here we also have 3.19 times 10 raised to the power minus 3. And you will now subtract the value you get here from this. Subtract it now. It will be 0.55 times 3.19 times 10 raised to the power minus 3. If you subtract it, the final answer you get is given us 0.547. So, and here, write this one down again. You have 3.19 times 10 raised to the power minus 3, then 3.19 times 10 raised to the power what? Minus 3. Again, what we now do now is what? We will write the equilibrium what? Constant. The equilibrium constant for what? For A, for B, which is base, is what? This will be concentration of NH4 plus and concentration of OH minus over what? Conc of what? Ammonia, NH what? 3, which is conc of ammonia. And here now, by substitute here directly, what is the value for this that we get here? This is 3.19 times 10 raised to the power minus 3, and we also have 3.19 times 10 raised to the power minus 3, close the bracket, everything over this. What is this one? Is 0.547. Please, so if you press your calculator very well, your final answer will be what? 1.86. 1.86 multiplied by times 10 raised to the power. Check the indices very well. Minus 5 mole per dm cube. So that is for what? This question. They can ask or text for Ostward dilution law in two ways in calculation. Do you be the word the first one? Do you be the word the second one? Let me just give you one example more in other words type. So let us solve this question. Find the percentage of dissociation and hydrogen ion concentration. You can see that what this example 3 is absolutely different from what? From this. Abi, but it's still under what? Ostward law. Find the percentage of dissociation and hydrogen ion concentration of 0.2 mole per dm cube ethanoic acid. So we are given the what? The molar concentration. Abi, solution. Percentage of dissociation. We are looking for the alpha unknown, and we are also looking for the what? Hydrogen ion concentration. Concentration of hydrogen ion. These are the two unknown we are looking for. And then we are given what? This. the molar concentration should be 0.2 mole per dm cube. And a dissociation constant, which is what? Ka is 1.85 times 10 raised to power minus 5 mole per dm cube. Good. And we all know that what? To know this dissociation constant by Ostward dilution law, say that the dissociation constant is square root of what? The dissociation constant multiplied by what? Volume. And then we are given what? The dissociation constant is going to be this. So the degree of dissociation, the percentage of dissociation is what is unknown. And then we have no Ka, but we don't know volume. So to know the volume from mole concept, we can say what? From molar conc, from mole equals to what? CV. From this expression, we can have what? Volume should be what? N over what? Over C. N is what? Number of mole. C is what? Is molar what? Molar concentration. Recall from the beginning, how many mole do we used to have? Is what? Is 1. So you will now have what? The volume of this, if you put it here, it will be 1 mole over what? What is the molar concentration? Is 0.2. I mean now, at the end of the day, the volume will give us what? Is 0.5. So the V equal to the what? Is 0.5 dm cube. Sorry, is 0.1 over 0.2 is not 0.5. So give us what? 5 dm cube. 5 what? Dm cube, that is the volume. So let us find the what? Substitute for volume and Ka here. Dissociation constant will be what? Percentage of dissociation will be square root of what? What's the dissociation constant? 1.85 multiplied by 10 raised to the power minus 5 multiplied by what? What is the volume? As what? Times 5. You now have alpha, which is what? Percentage dissociation of what? Of ethanol what? Acid. By pressing this 1.85 times 5, it will give us what? 9.62. 9 what? 0.62 multiplied by 10 raised to the power minus 3 mole per what? Dm cube. This is the what? Answer for percentage of dissociation. And you are now asked to find the concentration of what? Of hydrogen ion. Very easy. Look at this what? Reaction. Under this thing, the conc of hydrogen ion, it will be, remember from the beginning, under Ostward dilution law. Check it there. You can say what? From, let me say, to determine the reaction of hydrogen ion. Say what? From Ostward dilution law, the concentration of hydrogen ion is equal to the alpha over what? Volume, which is degree of what? Of dissociation. If you check the what? The way I proved that time. This is one concentration of hydrogen ion. And the degree of dissociation we get here is what? Is this. And the volume is what? Is 5. We now have what? The conc of hydrogen ion should be what? What do we have now? If we have 9.62 multiplied by 10 minus 3, everything over what? What is the volume? Over 5 what? Dm cube. Finally, the concentration of hydrogen ion, it will now give us what? 1.92 times 10 raised to the power minus 3 mole per dm cube. That will be the what? The final answer. So, like we are done with what? Ostward dilution rules. So the next thing now is what? We are going to treat what we call what? As the pH scale. From pH scale, you will look at what? pH and a pOH. From there, you will move to the what? To the buffer solution and their own pH. After that, it's like we are going to treat what? Acid-base titration. From there, we are done with acid-base concepts.